Hi, what's up, everybody? How are y'all doing today? Today we're going to be doing a lab in Cisco Packet Tracer. We're going to be doing a walkthrough of this enterprise network with a hierarchy design. Um, I'm not going to actually be like configuring the mop in this specific video. I'm just going to be, you know, I already pre-did the mop and everything. I'm just going to be showing y'all all the configurations that I did do on the mop, explaining the topology, like each layer, what they do and how they work. Because like if I were to actually configure them up in this video, it would be hours long, you know. But yeah, let's actually jump straight into it. So in this topology, we have three different layers, right? We have the access layer, we have the distribution layer, and we have the core layer, which connects to the backbone router right here. And we have this ISP router here that's acting as our wide area network or the internet, right? Yeah, let's actually jump straight into the access layer right here. So in the access layer, we have 5 different VLANs, right? And we have the admin VLAN, we have the IT, we have sales, we got the server right here, and we have the management, right? So basically, the purpose of the access layer is to, you know, uh, assign different VLANs, right? It's the other purpose is like to just connect to all the different hosts we have and to basically forward traffic upstream, right? In this layer, there's no routing at all, right? That's in the distribution layer. But let's actually go to the specific configurations that I did do for the access layer. Um, so in the access layer, the configurations aren't anything too complicated. It's just to basically create the VLAN, make uh, the interfaces that are connected to different hosts right here into access ports, and the as well as the interfaces that are connected to the distribution layer into trunk ports, and to configure like RSTP, you know, rapid spanning tree, uh, uh, BPDU guard. Um, yeah, that's mainly it for the access. It's pretty much the same, for each of the different layer 2 switches right here. It's just the only difference is, just the different like VLANs, this one, like which IT, that's the main difference. This is all mainly the same thing. But let's go into the distribution layer though. That's where like our main thing is, right? So in the distribution layer, this is where all our inter-VLAN routing happens. This is where all of our OSPF routing happens. This is where all of our DHCP relay is. This is where all the ACLs are configured. This is our main part of our network, right? This is how the network basically routes between everything, right? That's the main thing. So as well as the specific like configurations for it, where anything, it's just making, giving IP addresses to the different interfaces that are connected to the core layer, and the VLAN. This is also where our default gateway um is for our VLAN right here. This one specifically does routing for the admin VLAN. Um, this is where OSPF is right here. We have OSPF, um, the router ID, the summarized network, as well as uh, the wildcard mask in the area, um, spanning tree right here, and this is the part where the interface that connects down to the uh, layer 2 switch is, and the one that also connects to VLAN 20 as well. But this right here, this is where our ACLs are, right? ACLs, if you don't know what ACL are, is basically just access control lists, which is kind of like it functions kind of similar to a firewall, but it's not. It's you can kind of think of it as like similar to a firewall, basically, right? But for this specific ACL, our goal was, so our goal was to basically, we wanted um the admin VLAN to be able to communicate with all the different VLANs, but we did not want the other VLANs to have access into the admin VLAN, right? So the way I did that was to you basically have to permit ICMP, but ICMP basically just means ping, right? That's all that ICMP means. You have to say permit ICMP. I did the excuse me. I did the network ID for the VLAN 10, and this is like the wildcard mask. Any echo. Um, the purpose of this specific line, this command is so we could have so the VLAN 10 could basically, the ping could basically leave this VLAN, right? It's to basically just just to permit it to leave. And if you permit it to leave, then you have to also permit it to come back into the um interface, right? You have to let it come back in. That's what the second line is for, right? Permit ICMP any of the uh, network ID for the VLAN 10 and the wildcard mask, and then echo reply. Deny ICMP basically just like, just to deny anything that is not, just to deny anything that is not the network ID for VLAN 10, right? That's what that is for, and then the wildcard mask. And then permit IP any, basically permit IP any just means like, just to let any other types of traffic like OSPF to come in. That's what that means, right? And then interface VLAN 10, basically just go into the interface and then add the access control list in. That's what that basically just means, right? Yeah, so there was also but actually before I get into that, most of the distribution layer commands are similar. This one does not have any the specific VLAN 20 does not have any ACLs configured. It's just the IP addresses and the gateway IP for the gateway IP for the VLAN 20 and OSPF and RSTP. And it's similar for distribution layer 3 as well. For this one's similar, but for distribution layer 3 switch, I think this is 4. This one has an ACL, right? Which is right here. So the purpose of this specific ACL was so we wanted basically only the admin VLAN and the management VLAN to have access to the server VLAN. I didn't want sales or IT to have access. I only wanted management and admin to have access to that server. And what I did was basically just you create the access list right here, and then you permit um you permit VLAN 10, which is the network ID of VLAN 10, and the wildcard mask, and then you also have to add the network ID of VLAN 90 as well, and then echo, which is basically just to let um, VLAN 10 in, and then as well as uh, the management VLAN, which you do permit ICMP, um, as well as the network ID for VLAN 99, which is the management VLAN, and the wildcard mask, and then the network ID of the server VLAN, and then the wildcard mask of the VLAN, the server VLAN. And then you also have to do the echo reply for, I know that's just how ACLs work. You also have to do that because if you don't add the echo reply, it's not gonna let no traffic in. Like you're gonna be able to come in, but you're not gonna be able to leave. I mean, you're gonna be able to leave, but you're not gonna be able to come back in. So you also have to add the reply for the VLAN 10 and VLAN 99. You just basically just do the opposite. You start with you do permit ICMP, and then the network ID of the server VLAN, the wildcard mask, the network ID of VLAN 10, and then the wildcard mask, and then echo reply. And then same thing for the management VLAN. And then basically just deny any traffic that is not uh, the server VLAN, and then permit ICMP, just to permit other types of traffic like OSPF. And then you add it to the interface of VLAN 90. You know, those are the two ACLs that I have configured in this distribution layer. But yeah, I'm pretty sure that's pretty it for the distribution layer. It's pretty much the same thing for uh, this number 5 and number 6 as well. They're pretty much the same thing. Um, oh, I forgot to also add this. Also, the IP helper address of the DHCP server, right? This is where you also have to add the IP helper address, which is the server VLAN, into the interface of the VLAN, the different VLANs. And then for the core layer, for the core layer, it's just adding the IP addresses to the different interfaces. Oh yeah, I also forgot to say I did add a bundle right here to the between the two core layer 3 switches. Just for redundancy reasons, just in case one port goes down, then the second one will automatically come back up, right? That's what that's basically just for. And it's the configuration for is specifically right here. You know, um, you create the port channel. You say no switch port. Because if you don't do no switch port, then it's just gonna make it seem like a. If you don't do no switch port, then you can't do routing. I mean, you can't add an IP address to it. That's what that basically just means. And then you add the IP address, and then you do the same thing for. Oh, you also have to say whether it's active or not. So this the active side, and this is the passive side. Um, let me go to actually with that one right here, which is right here, right? Just create a port channel, no switch port, the IP address, and when you add it to the specific interfaces, you gotta say passive, right? Channel group mode 1 passive. That's for that. Pretty much the same thing, just the add IP address to all the different ports. And then OSPF right here, and then yeah, it's mainly it. Oh yeah, also what I did was I added so the what was I about to say? The Yeah, so this one's when you do a rapid spanning tree, this one mainly does, the root primary is just for this one does VLAN 10, 30, and 90 as the primary, and then the secondary is 20 and 99, and then the same thing for um core layer 3 switch 2. Just this one does the opposite, which is the root primary is mainly just 20 and then 99, and then the secondary is 10, 30, and 90. That's it for the two core layer 3 switches. Now let me move on to the backbone router, which is not right here. It's right here. Yeah. So in the backbone router, um, the specific configurations that I did do were just add IP addresses to the interfaces, and then OSPF, and then as well. Oh yeah, this is where our NAT/PAT is configured. So if you don't know what NAT is, NAT basically just means network address translation, and its purpose is to convert private IP addresses into public IP addresses. So if you didn't know, you can't surf the internet with a public IP address. I mean, with a private IP address, you need a public IP address. So that's what basically NAT does, is it translates a private IP address to a public IP address. But for this specific topology, I'm not using NAT. I'm using PAT. And what PAT means public. I mean, not public, but port address translation, which is it converts one private IP address into multiple public IP addresses. That's what PAT does, and that's what I'm using for this specific topology. Yeah, so you just add the you say whether the so this is you say whether it's an outside interface or inside interface. So I mean a inside IP NAT outside or IP NAT inside, and this one is IP NAT outside, and these two are IP NAT inside, right? That's what I did for that. You create an IP address for it. You add, so for PAT you have to PAT. You basically need a ACL for it, and that's what this is right here. The ACL for PAT, and then IP NAT inside for the where is it? IP NAT inside source list one, which these are the two, and then FA overload. That's how you know that it's PAT. You do the overload command, right? And then you just add it to the different interfaces, the two different interfaces. I mean, just you add it to the outside interface, which is right here, and then you go into these two interfaces and you declare if it's inside or outside. And then you also, oh yeah, you also have to add a default route. Basically, um anything that is not this 10.0 network, anything that is not like this 10.0 network, it's just gonna send it straight to this backbone router, which is gonna send it straight to the wide area network. So yeah. But before I do that, let me actually do a connectivity test. Um, so let's actually let's actually go into the admin VLAN, and let's see if we can ping the no, let's actually go to the IT VLAN. Let's see if we can actually ping the admin VLAN, because we have the ACL configured here. So I just want to make sure that it's up. I don't know what the IP address for this one is. Let me just see. So this one is 10. Okay. Let's go right here. And let's do ping. .10.3. Okay, so that's good. Let's go to this host right here and try to ping VLAN 20. Let me actually see the IP address for this one though. 20.4. All right, let's actually try to ping this host right here from the admin VLAN. It should work. So let's do a ping 10.0.20.4. I think it was. Was it 4? Yeah, it was 4. So yeah, it went through. Let me show you guys it through a simulation, like the actual packet going in there, just to make sure. So I can just do this, but let's do the simulation though. Let me make this full screen though. So as you can see, the packet is moving, right? But yeah, see, it's being blocked by the ACL, so it can't go in there. So then it just goes. It's gonna send a yeah. It's gonna send that it can't. It's gonna send a reply saying that it can't reach it. The host is unreachable. But yeah, so the ACL is working right there. Let's actually try to ping the server VLAN from this. But let's go see what the IP address is for the this one. Okay, so it's 90.2. Let's try to ping this host from this host right here. Ping 10.0.90.2. So it's also saying that it's unreachable. And now, let's try to ping this host from the admin VLAN, from the admin host. Ping 10.0.90.2. Okay, it worked. So the first one right here kind of failed due to like ARP, but let's if we do it again, it should say because right here it says lost one, but we can do it again. It should not lose any packets. Yeah, see, 444. So we know that the server ACLs, so the admin ACL can ping the server VLAN, but now let's actually try to ping the server VLAN from the VLAN 99, the host from the management VLAN. Ping 10.0.90.2. Okay, that one worked. Worked on the first try. But yeah, so that's actually working. And then now yeah. Now actually let me try to ping the let's do it from let's do it from the sales. Let me actually try to ping the backbone router. I believe the IP address for the backbone router was 10.1.1.1. All right. Okay, so that works. Now let's try to ping the wide area network, right? Let's do it. See if that works. I think that one was 2.203.0.3.2. All right, we got a reply back. Oh, first try. Yeah. Let's go to the backbone router and then let's actually see the NAT actually working. So let's do IP NAT address translation, I think. Address, was it IP NAT? Oh, IP NAT translations. Yeah. I think it was, oh, show IP NAT translation. Wow. IP NAT translations. Yeah, see? We have it right here, it worked. So, yeah, so that's basically gonna be it for this video. Oh yeah, I also want to talk about like ways we could actually improve this network, right? So if someone were to ask me what are ways we can actually improve this network, I would say mainly is to add a second DHCP server right here, because like if this server goes down, then we're not gonna be doing we're not gonna have we're not gonna have no DHCP all right here, right? Everything's not gonna be able to communicate with each other, right? So the main thing I would say is to get a second DHCP server, mainly for redundancy reasons, right? And this is a very let me add, this is a very scalable network, right? This is easily scalable, right? You can add different BGPs, different autonomous systems, um, and yeah, this is a very scalable network. But that's the main thing I would say is to add a second DHCP server. But yeah, that's gonna be it for this video. Thank you guys for watching. If you guys want me if you guys want me to send you the specific lab or the specific packet tracer file so that you guys can do it yourselves, then let me know in the comments and then I'll send you the file for it. But yeah, thank you all for watching and see y'all in the next video.